this optimization will be the fastest way to copy all bytes. So back to my implementation of transferTo. So what transferTo does first is checking again that the parameter is not null, because it makes not much sense if you pass in null here to do a lot of things up front and then you need the parameter or the pointer and you cannot dereference it. That makes pretty much no sense. So to fail fast, do it always as the best practice, always fail fast parameter checks. The last thing it does is call the original implementation. So this is just a future-proof code because I want to do a lot of improvements. As I said, I want to improve sockets, I want to improve files, I want to improve file to socket, socket to file, everything like that. But I have not yet merged it into OpenJDK. It exists on my hard disk. This is the proposals that will come in near future. For now, I only have improved file to file. So I'm checking here. Is the output stream where I want to write to actually a channel output stream? So is it that class that I created? Is it that particular class? No fear, you don't have to deal with that class. Just do channels, new input stream, channel, new output stream, and then you have that class. No need to create that or even know that it's there. So you just have the input stream, the output stream, to transferTo, and under the hood, my implementation notices that you have such an input stream and such an output stream and it matches them. So it knows that both ends actually are just wrappers around operating system memory. And because it knows that, it then checks what is actually wrapped. So we see we actually have wrapped a file channel on the source side and a file channel on the target side. So now we know for sure we actually have memory on behalf of the operating system, which is the file buffers, and we don't touch them. We don't touch them. We know there are these buffers, and we then want the operating system to move bytes from here to here under the hood outside of the Java virtual machine. And for that I wrote this method which says transfer the incoming file channel to the outgoing file channel. And then we go into the next method. So inside of this method that I wrote, which is getting a source file channel and a target or destination file channel, you can see that we are grabbing the original source position. So this is accessing the operating system to get hold on the position where is the source channel now. And we need that later. And then it is trying to do iterations over this method until pos. So this is the number where it actually is currently. So it starts with the initial position, but it will increase until this position is smaller than the file size. So why is it doing that complex thing? You would say, well, that the file size cannot change. That makes no makes no sense to actually ask for the file size again and again and again and again. This is slow. Actually, yes, it's slow, but imagine that you have two threads and one thread is cutting down the file size while you're transferring bytes. there's a problem. You need to stop immediately. If you don't do that, you have an endless loop. And thank you, Alan Bateman from the OpenJDK team at Oracle, who told me that in the review. Same situation when you extend in a second stream the original file. You don't want to miss that new bytes, because the description of transferTo actually says, if you read it in full length, that this method guarantees that it transfers all bytes from the source file to the target file. So all bytes literally means even if you extend the source file in parallel. So here you can see how complex it actually is to do this thing right. I can remember having written file-to-file copying loops a lot of times, thousands of times possibly in the past 30 years. And I never thought about what happens if another thread cuts or truncates the source file or extends the source file. The result will either be an endless loop or missing out bytes. This is really interesting what you can learn in reviews. So always be focused on what your reviewing parties tell you. This is really something we all can learn from. So you could say, well, I actually don't care for that. Yeah, me neither. I never cared for these cases, but in all previous thousands of times I wrote this copy loop, it was inside my application, and my application has no second thread. So I had full control that nobody, well, possibly an external program, and I cannot do something then, but my applications never cared about this parallel access. So, and this is fine, because you have control about the use case. It's your use case. It's your customer. You can discuss with him. You can have a limitation on the external access or whatever. You have control of that. But this is the Java runtime. We're talking about a piece of code that has no clue what you will do, or your application will do, or your customers will do with this application. So it must be prepared. It must do its very best to never fail, never ever fail. Try its very best to never miss bytes, to never copy the wrong bytes, to never turn in an endless loop. Imagine what happens if this runs in an endless loop. This is the Java runtime. You don't want your Java runtime to hang up. The telephones at Oracle will never stand still, or at IBM, Red Hat, Azure, they all have hotlines. The phones will ring the whole day. So this is a thing that must never happen. This is what Oracle told me that I must correct before it gets merged. So this is why the process of merging it took so long, because you need 2 reviewers to make this work correctly. They all had good ideas, but not a single one had all ideas what potentially could fail. So really brilliant in the review to find these 2 things. And while it does slow down, it must be that complex. So what are we actually doing here? What we do here is that we actually call the transferTo method on the source channel. So while it has the same name, this time it's not an input stream. So we're not dealing with bytes in the Java heap memory. We talk about channels. So this one directly gives the order to the operating system that the operating system is in charge of copying the complete content of one file channel into the second file channel. So what you literally say to the operating system is copy this file into that file. So we have one limitation here, or one limitation and a risk. Limitation first. The limitation is the length is limited to a long. Well, I don't see actually that there is a file system currently that can have files larger than long. Maybe that do exist, but I think nobody on Earth ever, no, well, not ever. You would say 64 kilobytes is good enough for error. No, I would say that least of us will see the day when it is a common problem to have files larger than a long. Okay, I think we can agree on this. At least not me. I will go into. I will not work after the next 20 years, and it would not happen before 20 years. Okay, back to the actual topic. So this is the limitation, and the risk we have. The risk we have is that this method actually is allowed to not really copy all the files, but stop prior to that. If it stops prior to that, you will gain the actual copied file size or number of bytes it actually moved here as a result. So what we do here is actually that we say try to copy the complete content, well, at least for the next 20 years, from channel 1 to channel 2 inside of the operating system. Don't touch it, don't bring it into the virtual machine's memory. Just from the file system to the file system inside of the operating system. And if it fails to do that, then we try again until we are sure that we actually are done, because we have possibly the risk that the operating system, why ever, does not copy it completely, but does it in chunks or whatever. And we can pick up then and do it again. Or, this is what I explained before, or we have a parallel thread that increases before transferTo is done. transferTo does not see that. It does not see that. So we give it a second attempt to pick up the new size and do the rest of the files. So if we are done with that, then we reposition the original channel to be at the end of the copy. Why that? Because when we come back from transfer, there could be a second thread. And the second thread now picks up again on the source file, extends it again. And possibly you wrote my code in such a loop too, just like the one here. Your application might say, well, currently a second thread extended a file after we returned, and your application picks up the same algorithm to be absolutely sure that everything is copied, calls transfer again, so transferTo, sorry, calls transferTo again. So we come back here, and to be at the correct starting position here, we have to ensure that the position is set on the channel, because just calling transferTo, sorry, here, just calling transferTo won't do that. So this is just a safety means that when you call transferTo again in your application, that it will work again, or possibly call any other method on that stream. So this is my optimization, and I said on my machine I have Windows 10 with latest updates on fastest laptop I could find with really really fast SSD. I could double performance, and doubling performance means this now is the fastest way that you can do to copy all bytes from an input stream or from a file input stream to an input stream that is targeting a file. At least as long as you go through files, new input stream, files, new output stream, or through channels, new input stream, channels, new output stream. In those cases, this optimization will be the fastest way to copy all bytes. So this is what I did, and I will show you what it's tested like, which is also interesting, but I will first show you the difference to what Oracle did. I said Oracle picked up my algorithm, and I will show you the change in that here too, before we go into that. Okay, so here we have the file input stream in the version of OpenJDK 18. And as I said, Alan and Brian from Oracle, they copied my algorithm to improve the file input stream and file output stream. Having said that, please don't use file input stream, file output stream. I personally would say it's obsolete, it's outdated. Really go with the files API. Go with the files API. Since Java 7, it's there and it's much faster and better. And well, there's a video from me about that. Look, watch that video. Okay, so but for your legacy code that goes with file input stream, they copied my algorithm, and they did one change. If you look at this code, you do not see the loop that I did. This loop, which is there for the cases I told you, for not coming into the situation of a truncated file leading to endless spinning or missing out bytes. They have a different solution, which is simpler, but which will not be that fast as mine, because they call the operating system a single time. They ask the operating system, please copy all that file, that bytes. Okay, nice. So as I said, the operating system possibly has not copied all the files. Why ever? For example, an external application changed the length of the file. So they do not pick up from this situation. Instead, they simply go here. They fall back. So there is one fallback here. They say if the new position is larger than FC size, then they return the number of transfer bytes. Nice. If not, they fall back here. So they deal with the same situation in a different way, and the way they deal with is to call the missing bytes in the original loop. And this is the slow one, right? This is the ugly slow one. So their judgment is like this. They say if that rare case really happens, then you won't notice that it's so slow. I have a different opinion. I think mine is superior in performance always, so why shouldn't I do that loop? But as you can see, same problem, different solution. So this was the implementation source code, and next we will look into the test, because testing your code thoroughly is really needed for the Java runtime.